So continuing with the FIR filters here, the next topic of our FIR filter design is design of a filter using frequency sampling method. Okay, design of a FIR filter using frequency sampling method. Frequency sampling method. Okay, so there are two types of these methods. One is type 1. There is one called as type 1, and there is one which is type 2. So there are two kinds of design methods in frequency sampling method. Okay, so the idea here is the idea here is you will be given some kind of a desired response. So in a FIR filter, so let's say you have an application for which you want a certain HD of e raised to j omega, which is your desired frequency response. So think about like a small application where you want a filter to be designed such that it cuts off all the frequencies below 2 kilohertz, or some kind of a frequency response is already there with you. Okay, and you want that frequency response to be designed. So that is your desired frequency response. Now what you do here is we will take the type 1 first. So here what you do here is you sample this. So let's think about a frequency response which looks something like this. Okay, so let's say this is a HD of e raised to j omega that you want to design. Now let's say this is from 0 to, let's say, pi by 2, or okay, 0 to pi by 2. So since it's like from minus pi by 2 to pi by 2, this is from pi by 2 to pi, it is 0. So you know that it's symmetric. The Fourier transform is actually periodic, right? So what you will have is you will have another you will have a repetition of this particular spectrum from 3 pi by 2 to 5 pi by 2. Okay, 5 pi by 2, since this is periodic in 2 pi. So from 0 to 2 pi it will keep on repeating. Okay, so now what we know is this is the desired frequency response. So what you do is you take this desired frequency response and sample it. So in the type 1, what you do is you will sample this particular guy. Okay, sample it with an intersample distance of 2 pi by m, where m 2 pi by capital M. Okay, where m is basically the some kind of the length of the number of coefficients that you want to design. So let's say this is 2 pi by m, where m is the length of the filter okay, to be designed. Okay, so now 2 pi by m is the intersample distance. So what will happen is you will be starting off with like h of k. So let's say h of k that you design is hd of e raised to j omega at omega equal to 2 pi k by m, for k equal to 0, 1, 2 till m minus 1. So what happens here is you sample this guy. So this is the first sample at k equal to 0. At k equal to 0, h tilde of 0 will be equal to hd of e raised to 0 j omega. The omega is 0, right? Because that is k equal to 0, so omega equal to 0. So this is this particular frequency, this particular value sample here. This is your h tilde of 0. Okay, so same way h tilde of 1 is hd of e raised to j 2 pi by m. See, when I plug in omega is 2 pi k by m, right, is already there. This is the sampling, the rate at which this omega is sampled. So at k equal to 1, this omega becomes equal to 2 pi by m. So your h tilde of 1 will be the sample at 2 pi by m. So let's say this is your 2 pi by m. So this guy will be your h tilde of 1. So we'll keep on taking these samples. At 4 pi by m will be your h tilde of 2, and so on. So you will keep on taking the samples over this particular period. So you will split this up 0 to 2 pi into m points, spaced at 2 pi by m, multiples of 2 pi by m, okay, or 2 pi by m, and you will get your m points. H tilde of m minus 1 will be equal to hd of e raised to j 2 pi into m minus 1 divided by m. So this is your value. Now I know this guy here, when I sample this, it looks like these are the DFT samples. These are similar to your DFT samples. What happens in the DFT samples? You take a h of e raised to j omega, and when you sample this at frequencies omega equal to 2 pi k by m, I will get some samples which are termed as the DFT samples, right? So these DFT samples, so this h tilde of 0, h tilde of 1, h tilde of 2, h tilde of m minus 1 are your DFT, m point DFT samples of hd of n, right? Okay, so they look like DFT samples. So if I take a inverse IDFT of this guy, then I will get hd of n, which is your the hd of n, which is your desired, or the filter coefficients of desired, or the coefficients of the desired filter, okay, coefficients of the time domain coefficients of the desired filter. Now what you know is, for it to be a FIRfilter, you have to satisfy this particular property. That is, first thing is you should have a linear phase, okay, and it should have what you call as, for it to be symmetric, h of n should be equal to h of m minus 1 minus n, or h of n equal to h of minus of h of n minus n minus n, m minus n 1 minus n, right? So now one thing which you have to do here is, see, these are your this will be your h tilde of n, right? Here h tilde or h of n, I can say h of n, okay, here will be equal to 1 upon m, the IDFT. I am just taking the IDFT of these guys. So summation k equal to 0 to m minus 1 h tilde of k into w minus kn of m, right? This is what your formula is. Now one thing which I want here to be done is, h of n has to come out as a real coefficient. H of n should be all real. For it to be real, what I will have to have is, I know that this guy here is a complex quantity, right? This guy here is a complex number which will come out. Now I need the coefficients or this particular samples to be such that the h of n which I get is a real quantity. for it to happen, for it to be true, all the imaginary components should cancel out, right? All the imaginary components of this particular equation has to cancel out, have to cancel each other out, right? So that you are left with only the real coefficients. So one way you can do that is if you force them to be like the complex conjugates. If you force them that these guys are your complex conjugates, then it will be true, right? So let's look at that part. Okay, so first requirement here is you know that the IDFT h of n, here is the formula is 1 by m summation k equal to 0 to m minus 1 h tilde of k into e raised to j 2 pi k n by m. Okay, now h tilde of k, what exactly happens here is this guy here is a phasor. We have already spoken about it. This guy here is a phasor. So think about, like, let's say this is your phasor of unity circle. Then what will happen is so if think about the cases where m is odd, okay, m is odd, and let's say we start with m equal to 3. If m equal to 3, then there will be 3 phasors. One phasor will be pointing with angle 0, the second phasor will have an angle of 120 degrees, the third phasor will have an angle of 240 degrees, right? So something like this. So let me just something like this. This is your 0, okay, this guy here is your, and this guy here is your 240. So something like these 3 phasors is what you will get. Now you know that already, we know that this here is your this here is your real part, this is your imaginary part, and this is your real part. So I already know that these phasor are complex conjugates. These phasor are your complex conjugate, right? So if this is a plus jb, or so let's say if this is minus a minus jb, right, this is in the third quadrant, then this will be minus a plus jb, right? So think about another scenario where I distribute I have m equal to 5. So think about another scenario where m equal to 5. So now these phasors will be like something like this, right? So first one will be here, the second guy will be here, the third guy will be here. One second, let me, okay. So the first guy will be here at 0, the second guy will be at 60 here, the third guy will be here, fourth guy will be here, okay, here, one second, yeah, so this is 180, 120, then this fourth guy will be here, fifth guy will be here, one second. So this is, let's say so let's say m equal to 5, so 360 degrees divided by 5 will be 72. So think about this guy as, this will be first guy, this will be second, this will be the third phasor, this will be the fourth phasor, this will be the fifth phasor, right? So something like this is what you will get, okay? Just excuse my drawing abilities. Yeah, so this is what you will have. So if you see this is your real part, this is your real part, this is your imaginary part. So if this is, let's say, c C minus JD, then this will be okay, C minus JD, then this will be C plus JD. If this is A minus JB, then this will be minus A plus JB. So they are already complex conjugates, right? They are already complex conjugates. These phasors are already complex conjugates when M is even. And this guy is H of 0, okay? This guy is H of 0, or this phasor is a real quantity. This is a real quantity of magnitude 1, right? We already know that e raised to j0 is 1. Now the requirement here will be, if I multiply two complex numbers, right? So think about this, a plus jb into, let's say, another value e plus jf, okay, plus a minus jb into e minus jf. What do you get here is ae minus bf plus j ae plus af plus b, okay, plus ae minus bf, okay, minus jbe plus af. So what happens here is when you have this, I know is already existing, a plus jb and a minus jb are your phasors. Now if my coefficients h tilde of k's, okay, h tilde of k's are the amplitudes which I multiply these phasors. So these guys, h tilde of k's, are, let's say, complex conjugate numbers of each other. Then what will happen is my complex coefficients here will go to 0, will cancel out, and I will be left with 2ae minus bf, right? I know this thing using the complex geometry. So the first requirement, h tilde for h tilde of n to be real is, first requirement, let's say m is odd, then the first requirement is h tilde of 0 has to be real, okay, because I will be left with, it's basically going to be like, if when m is 3, right, m is 3, I will be having h tilde of 0 plus h tilde of 1 into e raised to j 2 pi by 3 2 pi k n by 3 plus h tilde of 2 into e raised to j 4 pi n by 3. This will be my h tilde of h of n, which is 1 by 3 into this guys. So if my this particular guys cancel out, the complex parts of this particular guys cancel out, then h tilde of n 0 is what I will be left with. So h tilde of 0 has to be real. Second thing, my h of k, h tilde of k has to be a complex conjugate of h tilde of m minus 1 minus k. So this I already know, because this here, if this is h of 0, then this is h of m minus 1. This is h of 1, then this is h of m minus 1 minus n, right? So something like this. So since it's a positive phasor, e raised to j, so I'll start off with this. So this will be h of 0, this will be h of 1, this will be h of 2, this will be h of 3, this will be h of 4. So my h of 0 has to be a complex conjugate of h of 4. Okay, h of 1 has to be a complex conjugate of h of 4. H of 2 has to be a complex conjugate of h of 3, and so on. So if in this case, this will be h of 0, this will be h of 1, this will be h of 2. So h of 1 has to be a complex conjugate of h of 2. So only in that case, these guys will cancel out, the complex coefficients of these guys will cancel out, and you will be left with only the real part. Okay, so this is the two conditions for when m is real, when m is odd, I want, the first condition is h tilde of 0 has to be real. Second condition is h tilde of k should be a complex conjugate of h tilde of m minus 1 minus k, for k varying from 1, 2 till m minus 1 by 2. Okay, 1, 2 till m minus 1 by 2. When m is even, first thing I will want is, see, when m is even, then there will be even number of coefficients right here, right? So everybody will have a pairing, a complex conjugate pairing. So think about this guy here, okay? So when m is even, this is how the phasors are going to move around, be split. So let's say m is 4, m equal to 4. When m equal to 4, what you will have is, this will be h of 0, okay? This will be my h of 1, this will be my h of 2, this will be my h of 3, okay? This right now it is simple. I mean, this is a phasor. This is your e of 0, 0. So now, if this is so let's say that the amplitudes are varying, right? Amplitudes are varying, something like this. So this guy has to be a complex conjugate. So h of 1 has to be a complex conjugate of h of 3. Okay, now what I am left with is h of 2. H of 2 again will be like some kind of guy who will not have any pairing with remaining. So in this case, this will be an issue. Think about m equal to 6. When m equal to 6, what you have here is, what you will have here is 6, so 60, right? So this is first, this is second, this is third, this is 160, 120, 180, yeah. So this is third, this is fourth, this is, yeah. So these guys are complex conjugates. Same way these guys are complex conjugates. What you will be left with is this guy will be alone, right? This phasor is anyway real. So if my h of, so this is your h of 1, h of 2, h of 3, h of 4, h of 5. Now h of 5 and h of 1 are complex conjugates, so they will cancel out. The complex parts will cancel out. H of 2 and h of 4 are complex conjugates. So h tilde of k is equal to h of m minus 1 minus k, either way, right? So if you have h of k as equal to h tilde of h asterisk of m minus 1 minus k, then they will cancel out. What you will be left with is a term which is h tilde of k into e raised to j 2 pi k by 6, 2 pi 3 k by 6, right? 2 pi 3 k by 6, which is pi k, okay? This is a minus 1. But then if your h tilde of 3 is a complex number, then this will not cancel out, right? So that's the issue. So what I want in addition to this, when m is even, is h tilde of 0 has to be real, h tilde of k has to be a complex conjugate of h tilde of m minus 1 minus k, and the third one is h tilde of m by 2 has to be a 0. When this is a 0, then it makes sense. If this guy is a 0, okay, then I am left with only h tilde of 0 and the other complex conjugates. H tilde of 0 is already real, that condition is already there with me. Then these guys, the result of the IDFT will be a real quantity. Okay, so in that case, what will happen is my h tilde of n or h of n will be 1 by m into h tilde of 0. So when m is odd, okay, and m is odd, plus 2 into summation k equal to 1 till m minus 1 by 2, okay, real part of h tilde of k into e raised to j 2 pi k n by m. So this is what I will get, okay, where m is odd. When m is even, then I will get h of n as equal to 1 upon m h tilde of 0 plus summation 2 into summation k equal to 1 till m by 2 minus 1, okay, into real part of h tilde of k into e raised to j 2 pi k n by m. So this is what I will get, and h of m by 2 is already 0, that condition is there with us. And then this h of n is going to be your designed coefficients. You will design a filter using these coefficients, and the design frequency response will be the Fourier transform of this, DFT of this guy, okay. Yeah, so h of z, the design filter will have a h of z equal to summation n equal to 0 to m minus 1 h of n into z raised to minus n. So this is what your design filter is going to look like, okay. So this is your type 1 frequency sampling method, In type 2 is actually the same thing. Type 2, it's the same as type 1, only thing is when we are sampling this, right, when we are sampling this particular guy, we take a frequency. In the previous case we had taken hd of e raised to j omega, where omega was sampled at 2 pi k by m, where k was from 0, 1 till m minus 1, right. Here what we are doing is, instead of sampling it at exactly 0, we take a offset sampling. So what you do here is, instead of starting the sample at 0, we start the sample at pi by m, okay. So pi by m, 3 pi by m, 5 pi by m, and it goes on till. So in type 2, what we do here is, instead of starting at 0, we start at pi by m. So the sampling frequencies omega k will be 2 pi k by m plus pi by m. This is what you will have. So the first guy will be for k varying from 0, 1 till m minus 1. So what will happen is, instead of starting at 0, you will start at a sample which is pi by m, then 3 pi by m, 5 pi by m, and so on, and it will go on till 2 pi by m, okay, 2 pi into m minus 1 by m minus plus pi by m, okay, clear. So that's same as like 2 pi, which is the last frequency will be m minus 1 will be 2 pi into m minus 1 by m plus pi by m. So which is 2 pi minus 2 pi by m, okay, 2 pi minus pi by m. This is what you will get. So this is wrong. This is 2 pi minus pi by m, okay. So for frequencies varying from pi by m to 2 pi minus pi by m, that's your variation going to be. So same way for m odd again, so your h tilde of k will be hd of e raised to j omega at omega equal to 2 pi k by m plus pi by m, okay, and this will be for k varying from 0, 1 till m minus 1, okay, and for m odd, the requirement is, first requirement is you should be having h of k should be equal to h conjugate of m minus 1 minus k, for k varying from 0 1 till m minus 1 by 2. Okay, and second requirement is that h tilde of m minus 1 by 2 should be equal to 0. Okay, this is just the reverse for m odd. What exactly happens here is, then since there is an offset of pi by m, right, you should be having so think about this guy here. Okay, initially you had a circle, the phasor was something like this, right? We had a phasor which was for m equal to 3 was looking something like this. Now only thing is, you got to write, what do you call, you just have to rotate this anti-clockwise by pi by m, so your new phasors will look something like this. Yeah. If I use m equal to 3, then pi by 3 is the offset, so this guy is going to be pi by 3, this will be at 150, and this will be at something like this. This is how it's going to move. So this guys here will be a complex conjugate, and this guy will be left alone, so that guy has to go to 0, okay. So h tilde of m minus 1 by 2 has to be equal to 0, and for m even, again the same thing, you have a circle again. Now since I will think about m equal to 4, so what will happen is, since m equal to 4, this guy is going to be distributed. Whatever was at 0 will be moved to pi by 4, whatever was here will be moved here, whatever was at pi by 2 will be moved here, and this way. This is how I am going to get. So they will already be complex conjugate. So for m even, my requirement is that h of k should be a complex conjugate of h of m minus 1 minus k. The whole process is forcing this to be complex conjugate is for h of n to be real. H of n has to turn out to be real. Now in this case, your h of n value will be real, and h of n will be equal to 2 by m summation k equal to 0 to m minus 3 by 2, since m minus 1 by 2 is 0. Okay, real part of h tilde of k into e raised to j 2 pi k n by m plus pi n by m. So this is what you have for m odd. This is for m odd. For m even, h of n is equal to 2 by m summation k equal to 0 to m minus 1 m by 2 minus 1 m by 2 minus 1, a real part of h tilde of k into e raised to j 2 pi k n by m plus pi n by m. Yeah. So just to summarize, what exactly happens here is, we start off with frequency sampling method, which is type 1 and type 2. In type 1 and type 2 frequency sampling method, what exactly happens is, you are being given desired frequency response. This is given to you. I want to design a filter which is having a desired frequency response, something like this. I want to design a FIRfilter. Now what you do is you sample this guy at points. For type 1, I sample it at 0, 2 pi by m, 4 pi by m, and so on till 2 pi into m minus 1 by m. In type 2, I just offset this sampling by pi by m. So pi by m, 3 pi by m, 5 pi by m till 2 pi by m minus 2 pi minus pi by m. This is what I have. Okay. So I know the intersample distance is still 2 pi by m. Okay. Where m is the length of the filter. M is the length of the filter. Now m can be even or odd. So think about the type 1 now. If in the case of type 1, I need these particular sampled coefficients act like DFT. They are like DFT coefficients. If I take the IDFT, I will get the h of n to be designed. Okay. So if I take the IDFT, which is this formula of the sampled desired response, I will get h of n. Now h of n has to be real, I know that, because it has to be there has to be a symmetric Fourier transform, and then the phase response has to be linear, right? So for h of n to be real, I need my h tilde of k to be following a certain rules. Okay, so we know that if I have m odd, then h tilde of 0 is one part, and the other components should be like cancelling out if I make my h tilde of k's to be complex conjugates. So when m is odd, h tilde of 0 has to be real, and h tilde of k should be equal to complex conjugate of h tilde of m minus 1 minus k. If these two conditions are satisfied, then my h of n will be real. Now for m even, I need h tilde of 0 to be real, h tilde of k to be equal to h conjugate of m minus 1 minus k, and the third one is h tilde of m by 2, that is the center coefficient should be 0, forced to 0. Only in that case my h of n will be real. Same way for type 2. For type 2, my two conditions are h of k should be equal to h tilde of h conjugate of m minus 1 minus k, okay, for m odd, okay, and my h tilde of m minus 1 by 2 should be equal to 0. That's because you have 3 or 5 or 6, 7, everybody will have a pairing except for one guy, so that has to be the middle guy. For m even, I need my conditions to be like h tilde of k should be the h conjugate of h tilde conjugate of m minus 1 minus k. So they are just exactly opposite in type 2. Okay, so we'll look at a problem after this.